Hello and welcome to my example tutorial on simultaneous equations. So before I get stuck into the tutorial, what I'm going to do is just give you a bit of context as to how I would tackle this within the broader teaching of the student. So normally this comes after linear equations. So the student is really comfortable manipulating variables, understands how to multiply and subtract equations to find out what x is or whatever the variable is. So they understand the terminology and they should have gotten to grips with most of the manipulative aspects of working with equations. It's also worth noting that I would try and understand what knowledge the student already has on the subject from the school. So I'd give some diagnostic questions and figure out exactly where they're up and what they're struggling, where they're up to and what they're struggling with. But for the context of this, I'm just going to teach it as though I was teaching it fresh. Now, if I was teaching a subject fresh, I'd take it really slow and I would interject a lot and make sure that the student understands exactly what I'm going through. If they're struggling with something, then I'd probably slow it right down and get them to do some examples, because the last thing that they want is for me to give them a 20-minute lecture on a subject, because they're not going to learn anything, basically. So I'll tell you bit way through where I might interject and get the students to do stuff. So without further ado, I'll get stuck in. Simultaneous equations, what are they? So a simultaneous equation is an equation with two variables. So for example, you could have x plus 2y equals 6. So by variables, I mean your letters, your x and your y. So your job is to find out what x and what y is. But there's a problem, and the problem is that there's actually an infinite number of possibilities for what x and y could be. And I can show you this. So if we just throw some values into this equation, say x is 2, let's try that. So if x is 2, the equation becomes 2 plus 2y equals 6. We know how to solve this. We take away 2 from both sides, so it becomes 2y equals 4. Divide by 2, y equals 2. So for that equation, x could be 2 and y could be 2, and that would work. So let's try a different value. Let's try x is 3. Throw it into the equation again, and you get 3 plus 2y is 6. Solve it in the same way as before. 2y equals 3, and y equals 1.5. So it works again. You've got another answer. X equals 3, y equals 1.5. And this is the problem. There's actually an infinite number of answers for this one equation on its own. And this is where the simultaneous in simultaneous equations comes in. Because actually, what you need is two equations with your variables in. So you could have x plus 2y equals 6 and, I don't know, x plus 4y equals 9. Just an example. And I can tell you that there is only one answer for this. And you'll see this when you work through them. Now the question is, how do we find that answer? And there are two methods that I typically teach. And that's the elimination method and the substitution method. And typically, I begin with the elimination method. That tends to be the one that students connect with the most. It also tends to be the one that schools teach first. So it's always good to get them really to understand this one first before moving on and teaching them something about substitution. Okay, so what is the elimination method? Now I've prepared some steps down here. the first step that you have to do, and you only have to do this some of the time because some of the time the equations already work for you, is to prepare the equations. Now this means manipulating one of the equations so that you can use this method. And that will become clearer once I've talked you through the rest of the steps. So then the second step is to do a whole equation subtraction or addition. Now what do I mean by this? Okay, so I'm going to give you an example with this equation. It's not going to give us the answer, but it'll show you what I mean. Let's do a whole equation addition. This is where you go through and you add each element from one equation to the other equation. Okay? And you can do this because we know from linear equations that if you do anything to one side, you can do anything to one side, but you have to do it to the other side. And because these sides are equal, because of the equals, we are doing the same thing to each side when we add or subtract a whole equation from another equation. So, to go through, what I would do is we're doing an addition, not a subtraction. X plus x, which is 2x. Four y plus 6y, 4y plus 2y, which is 6y, and 6 plus 9, which is 15. Okay, so that's what a whole equation addition would be. But this hasn't got us any closer to the answer, so it hasn't really helped us. And that's because it hasn't eliminated one of the variables from the equation. But you'll see that in this case, if we were to use whole equation subtraction, we might get a bit closer. So you do x minus x, that gives us 0x. You do 2y minus 4y, and you get minus 2y. And 6 minus 9 is minus 3. Now, the beauty of this is that 0x is 0, so you can just get rid of it. Which leaves us with minus 2y equals 3. Now, you can solve this because you've solved linear equations. So what I would do, if I was going through this, is I would times by minus 1, which would flip the signs. So 2y equals 3, and then do y. Then divide both sides by 2, which means y equals 1 and a half. And that is half of your answer. Now all you have to do is work out x. And the way I would do this is I would throw that y back into the equation. And I would substitute in my new knowledge, which is that y is 1 and a half. So to work out x, we're going to use this equation and sub this answer back in. So x plus 2 times 1 and a half is 6. Can you see how I've substituted that back in? So that becomes x plus 3 equals 6, which becomes x equals 3. And that is your answer. Y equals 1 and a half and x equals 3. Now at this point, I would talk through I would make sure that the student understood the examples, and then I would go through some questions with them. The first question I go through step by step and check that they understood everything. I might just get them to do some whole equation subtraction or whole equation addition, and then we would gradually work through more and more complex examples so that they've got broad spectrum covered and they're really comfortable for their exams. I'm not going to go through that now because I'm out of time, but hopefully this gives you a little bit of a taste of how I would go about a tutorial. Thanks for listening.